Today I will discuss about some fundamental theorem on differentiation. Right. First theorem, that is the differential coefficient of a constant is 0. The differential coefficient of a constant is 0, right? That is ddx of c equal to 0, where c is constant. Let y equal to fx equal to c, right, for any value of x. Now, as per definition of differential, that is f dash x equal to limit h tends to 0 f of x plus h minus fx divided by h, right? Now, here f of x equal to c, and also for the value of x plus h, the function is also c. Value of function is also c. Then we can put here and we get c minus c, that is 0, that is result is 0, right? Now theorem 2 is theorem 1. Now theorem 2, it is the differential coefficient of the product of a constant and a function is the product of a constant and the differential coefficient of the function. That means just we only write this ddx of, we have to prove c of phi x, right, equal to c ddx of phi x. We have to prove this. Now here c is a constant term, and phi is a function of x, right? Now here fx equal to c into phi x, right? Then f of x plus h becomes c into phi of x plus h, right? Now f dash x equal to limit h tends to 0 f of x plus h minus fx divided by h, right? This is equal to limit h tends to 0 f of x plus h, that means c into phi of x plus h, minus fx means c into phi x, right, divided by h, taking the value of c as a common term, that is c limit h tends to 0, as c is a constant term and it is independent of h, that's why we take it and you get phi of x plus h minus phi x divided by h, right? Now this is, we can write this as a phi dash x, right? C phi dash x, and it is proved, our result is proved. Now theorem 3, that is the differential coefficient of sum or difference of two functions is the sum or difference of their derivative. That means ddx of phi x plus or minus psi x equal to ddx of phi x, right, plus or minus ddx of psi x, right? Now here fx equal to phi x plus or minus psi x, right? Then f of x plus h becomes phi of x plus h plus minus psi of x plus h, right? Now as per definition, f dash x equal to limit h tends to 0 f of x plus h minus f of x divided by h, right? And substituting the value limit h tends to 0 phi of x plus h plus minus psi of x plus h, and for fx you can put here phi of x plus minus psi of x, right, divided by 1 divided by h. Now limit h tends to 0, phi of x plus h. You can separate here the phi function and psi function. That is phi of x plus h minus phi x by h as a using property of limit, right? Limit h tends to 0, psi of x plus h minus psi x divided by h, right? Now this is phi dash x and this is psi dash x. Hence the result is proved. Phi dash x means d dx of phi x, right, plus minus d dx of psi x. Now if we take the product of two function and its derivative, we get theorem 4, right? What is theorem 4? Theorem 4 is d dx of phi x into psi x, right, equal to phi x d dx of psi x, right, plus d dx of phi x into psi x. Now I have to prove this. So first we assume fx equal to, let fx equal to phi x into psi x, right? Then as per definition of f dash x, you can write as limit h tends to 0, f of x plus h minus fx divided by h, right? This is equal to limit h tends to 0, f of x plus h means phi of x plus h, psi of x plus h, psi of x plus h, right, minus phi x into psi x divided by h. Right, then limit h tends to 0. Now we can write as phi of x plus h, psi of x plus h minus phi of x into psi of x plus h, right, plus phi of x, psi of x plus h minus phi x into psi x divided by 1 divided by 8. Now taking psi x plus h is a common term from here, first two term, and phi x from second two term, we can write limit h tends to 0, right, phi x plus h minus phi x psi x plus h divided by h, right, plus limit h tends to 0, phi x psi x plus h minus psi x divided by h. Now taking separate limit for this and this term, we get for this term we get phi dash x, right, and for this term psi x, right, and phi x is independent of h, and for this term we get psi dash x, right. After rearranging, you can write phi x psi dash x plus phi dash x into psi x. Hence our result is